everyone, welcome to Modern Application Development Part 2. Alright, now we have seen objects in the form of arrays, not really objects in the generic class type, right, so far. What we are going to do is now spend a little bit of time trying to understand JavaScript's notion of objects. But before that, we also want to understand a little bit about how JavaScript allows you to encapsulate things into modules, right? And modules are very important from the point of view of reusability of code, okay? The whole idea of a module is that you collect related functions or objects or values together. From Python, you might have come across the NumPy module, for example, which basically collects a lot of numeric Python related functions together, right? SciPy is for scientific Python, okay? There are others for CSV, for example, right, which for dealing with comma separated values. And the idea is that you have a whole lot of different functions and classes that are all related, and you bundle them together into one or more files that can then be imported by others and used, okay? In JavaScript, same idea, right? You explicitly export certain values for use by other scripts, and you can then import values from those other scripts into your code, okay? Now, JavaScript has one problem, which is the fact that a lot of JavaScript is used on the front end, right? Which means that you need to be very clear about how you are going to import. Are you supposed to be importing from a local file? Where is the package present? Is it present somewhere on the net? Should the package be downloaded if required, right? And how do you sort of generally do this relative addressing of packages and so on, okay? On the other side, JavaScript is also used on the back end using the Node.js interpreter. And when that happens, well, you can use it just like Python, right? You have the packages, you define directory hierarchies, you put files in certain directories, and you can import them as required. So because of these two different ways of using it, we have to be a little careful about how we package things and how we are actually using the code in our programs, okay? Now, what happened is, when JavaScript started out, there was no notion of modules, right? And it basically just had scripts. You directly include scripts inside a browser and those scripts execute, okay? Now, once people started using server-side JavaScript, there was this notion of CommonJS, right, which was brought in order to implement what's called server-side modules. They wanted to actually package it and start using it more like an interpreted language. Now, CommonJS has some issues, one of the main ones being that it uses synchronous loading, right? And synchronous loading means that it basically, the moment it comes to the import statement, it waits until the import has completed before proceeding, right? Which is fine at the server end, because after all, it's running once, it imports and then it runs from there. But the moment you do anything synchronous or blocking, as it's called, on the browser, it's a big problem because it actually makes the user experience very bad. Okay, so any kind of synchronous loading or blocking loads on a browser are basically unacceptable, right? Because there might even be a possibility that you're trying to do a load from some server that is down, and what will happen to the end user, the page will just be completely frozen, because JavaScript works that way, right? We'll get to that later. So on the client side, on the browser side, there was another definition called asynchronous module definitions, or AMD modules. Now, ECMAScript 6, which was sort of formalized in 2015 and has been developing since then, brought in this notion of ES6 modules. Works on both servers and browsers. It uses asynchronous load. There are certain packages and possibly even certain browsers that do not fully support this, although browsers should pretty much support it at this point. What you might find is there are some relatively old packages that do not support ES6 modules completely as they should. Now, as far as we are concerned, we are going to go with the latest version of the language, because it's not really worth sort of going back and learning old versions of the language just to sort of keep up with those things. If you do encounter an older piece of code that you need, then you might have to sort of understand a bit more about how modules are written there in order to make use of it. Now, just a word about NPM, which is the Node Package Manager. Right, Node is a command line interface for JavaScript. It's mainly used for backend code. It can also be used for testing, right? And the interesting thing is, NPM can also be used in order to package modules for use at the front end, right? And this is usually done using so-called bundle managers, right? There is something called Webpack, there's another one called Rollup. There are a few different things that allow you to take the packages that were defined using node modules and put them into different JS files, which can then be directly included or imported even on the client side. Okay. Now, for the most part, we are going to ignore all of this. We don't need to know about it right now. But at some point, as and when you start actually, bundling the thing together into an application, you need to know a little bit more about how these work. Okay. For now, we are ignoring these aspects. Okay. So let's first look at modules, right? In JavaScript, we'll look at some examples. Going back here. So now let me look at the index.html first, and what I have is, right, if you look at this, you will find that there is this line 16 which basically says script source equal to modularity.js, okay, and this is basically the file that I'm going to show you, and it says that it's a type module, right, and it turns out this is important because if I do not have this type equal to module here, I cannot use import statements or exports for that matter inside it, okay. Now, more importantly, if I go look at modularity.js, I will find that I am only going to be importing things from here, right? And I then have the regular JavaScript functionality. Because I have this import statement out here in the index.html, I needed to have this type equal to module. Okay. But where am I importing from? If I look at modularity.js, I'll find that I'm importing from module1.js, right, which contains this code. So let me say that, I export this, right? But if I go look at the index.html, module1.js is nowhere in the picture. I don't have to put it as a script, right? Modularity.js automatically picks it up from the place that it is needed and runs it. So what happened in module1.js? I just have a single line, export const c equal to some number, right? And in modularity.js, I import c from module 1 and print it out. What happens when I run it? As expected, it got the right value and printed it out. Okay. So this is the most basic form of how I can import something from another module, right? But why would I do this? I could have just declared const c in the other file to start with. Instead, I can do something else, which is that let's say I do this, right, which is, oops, this top line should not, yeah. I define one function, right, so in module1.js, in other words, I have a function which is sq of x, which will square a value, okay, and I also declare a const c, which is exported, so this can be used somewhere else, and another function energy, which can also be exported, and which makes use of this sq of x function, okay. So both of these, the value of c, a const, and this function energy are being exported, and I'm going to import both of them out here, okay, import c comma energy, right. What will happen when I run this console.log of c? Sure enough, I get the value out here. What happens if I console.log energy? I get that value as well over here, right. Now, of course, I probably need to try importing the value sq as well before I can actually run console.log sq of 10. But what happens when I run this? It says the module does not provide an export named sq. Okay, so because I did not have export in front of this function sq, it does not allow me to import it over here, right? So I have to basically lose this. If I try running it, it's just going to say sq doesn't exist, right? And when I finally run only these two, yeah, sure enough, that works. Okay, so this is sort of the most basic form of importing. Right? I can do something further, which is basically I can rename an import, right? Which is to say that when I am importing C, I can rename it as speed of light, and yeah, from there onwards, I have to use the value speed of light in my code. Okay, so that's just in case you want to sort of change the name for internal use. Okay, and now there is something further that I can do over here. There is also another format in which I could do the same thing, which is to say that I will need this as well. Yeah. So now what I have is, if you look at this way the code is written, I have const speed of light equal to this, function e of m equal to this. But now when I'm exporting, I'm saying export speed of light as c and export e as energy. Okay. And what I'm saying is I'm sort of renaming the export, right? So that when I finally go back over here and I run this same thing, right? I import c comma energy and I run it, it just works exactly the same way as before, right? Because as far as module1.js is concerned, even though internally it thought the value was called speed of light, when it exports it, it calls it c. So as far as the other file is concerned, it imports it as c. All right. Now there is also a notion of something called a default export. Okay, and what we can see over here is, in this module1.js, I have declared a value, right? I'm not exporting it, and I'm exporting a default function, right? I'm not giving the function a name. Normally it would have been function energy of m. Instead of that, I'm just saying export default function. In other words, this particular module is exporting only a single thing, right? In this case, it happens to be a function. How would I do this? I can't then do import c comma energy because they are not being exported, right? But if I just do import energy, right, it takes whatever was the default export from module1.js and gives it the name energy for use inside my code, right? And I can directly run it and it would give me the value that I expect. Okay, and there's one last part which is actually quite interesting to observe and is worth understanding in terms of how modules actually work, right? I'm exporting two things over here. One is a value x and the other is a function incx. Okay, now this value has been declared using let, not const. Okay, which means that I should be able to change that value, right? And sure enough, this function incx is actually able to modify that value, right? Now let me go to this modularity and say I'm going to first import x and incx. Sounds good. Log the value of x. Okay, what should I get? I should get the default value, which is 0. Okay. Now after all, x was imported, x was declared using let. Can I change its value? Nope. It says assignment to constant variable. Okay. In other words, even though x was declared as a let inside the module, when it comes inside, when I import it, I get only a read-only view of exported variables. Does that mean I can never change it? Again, no. I can call the function incx, right? And by calling the function incx, what happens? Well, I should have printed out the value. It does change the value to 1. Okay. So in other words, the only way of changing a value that is being imported is by calling the functions so that were also written in the same scope as the value that was being exported. Okay. And by doing that, we can basically have this kind of, the behavior that we want, where we are actually have a value that changes over time and can be modified, but cannot directly be modified using something like an x++ over here. Okay, so that's an interesting thing to keep in mind when you are sort of exporting variables. Now, in general, of course, you need to think a lot before you create a module or exports or anything of that sort. So please don't just take this and say, oh yeah, maybe I can export it like this and not use it the other way. Before using any of these exports or imports, you need to think clearly about how you are structuring your code to start with. Okay, so we looked a little bit at what modules are and how they are implemented. Now let's understand a little bit more about objects in JavaScript, right? And over here the thing is, everything in JavaScript is an object, right? There is this notion of object literals that are used to assign values to named parameters in an object, and there are object methods, which are functions that can be called on the object. Okay, there is also the special variable which is labeled this, right, which is found inside objects. We'll get to that in a moment. There are also certain other functions like call, apply, bind, and so on, which are again interesting to know. They are sort of functions of functions, so to say, right? And as mentioned earlier, right, there are certain standard methods that belong to object, the parent class, like keys, values, entries, and so on, right? So you can use an object as a dictionary, and in this case, these things allow you to sort of iterate through the values in the dictionary, right? Now, JavaScript has a notion of object orientation, but not exactly in the same way that other languages like Java, for example, or even Python have, right? So this notion of class in JavaScript, first of all, the keyword class now exists, and you should use it because it sort of makes the coding much cleaner. The point is that it actually works using something called a prototype, right? So rather than saying that an object is inheriting from another object, what you are actually saying is I can just create two objects and I can set the prototype of one object as the other object, which means that it automatically sort of gets all the behavior of that parent object. Okay. Now, this also means that there is sort of a single inheritance track. You always have one direct parent relationship, unlike the sort of multiple inheritance that are there in other languages. Now, in most cases, when you are using things like multiple inheritance, it is something to be done with a lot of caution in any case, right? So the fact that JavaScript does not allow this is not necessarily a sort of showstopper problem. It does mean that you need to change the way you think about certain things. And in a lot of cases, you will find that, you can actually get by without necessarily having to use things like multiple inheritance. And this prototype based inheritance is actually quite powerful in itself. Okay. Like I said, there is this notion of a class, right, which primarily acts as a better syntax and a cleaner way of writing the code. Okay. You have this notion of constructors, and in this case, they must explicitly call the parent constructor. Okay. There is a way of implementing mix-ins or multiple inheritance, but it's somewhat complicated to implement, and definitely we are not getting into those details over here. So let's look at some examples of implementing objects in JavaScript, right? And what we'll do is start by just creating a most basic object. It just prints out what the object is. Now the interesting thing is I can do more. I can directly add a function, right, as one of the elements in the object. I can basically say xx.add is equal to this. And what happens when I print this out? I can say xx is of type object, xx.add is of type function, and when I evaluate xx.add with 3, 4, it actually gives me xx.add 3, 4 is equal to 7. That is, in other words, it calls this function, adds 3 and 4 and gives me the output. Okay. So in other words, xx.add is now a method of this particular object, right? We don't have classes yet. It's just an object with its own methods. Now, I could go further and say I declare a new function xx.f is equal to just an anonymous function, a function of x, which returns this dot a. Okay, so what is this dot a? The parameter this over here refers to the object. Okay, and of course, it's like the self in Python or this itself in Java, right? It refers to the object, and this dot a, as we know over here, has the value 5. Okay, so when I run f with a parameter passed into it, I should get 5 added to it as the result. Okay, and yes, sure enough, we can see that 10 plus 5 is equal to 15. Okay, so in other words, this over here is a useful parameter to have, which allows us to refer to the object itself and to other parameters of the object, right? If I directly tried saying return a plus x, it would not work because it doesn't know what a is. There is no variable called a in this present scope. Okay, let's just comment this out. Now, one few interesting things, especially they can be tricky. So you need to keep this in mind. What happens when you copy an object, right? I say x is equal to a12, y is equal to x, and obviously when I print them out, I get the same value. So far, so good. Okay. But now I assign a new value to x dot a, and I'm going to once again print out the values of both x and y. Okay, and what do I see? Both x and y have changed, right? The a has become 3 in both cases. In other words, y over here did not actually get the values of x. It's pretty much just a pointer to x, okay, or a reference, whatever you want to call it, right? It's the equivalent of just basically taking a pointer to x. So what does that mean? Does that mean that we can't take copies? Well, here comes the spreading operator again, right? When I say z is equal to dot 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 x, it spreads the values of x out. Now I change the value of x dot a, right? Print x, print y, and print z. Okay, and what do I see? I find that finally, let me get rid of the other console logs because you already know what those are. The last 3 values alone, x now has a equal to 5, y still has a equal to 5 because after all y is just a pointer to x, but z does not. Z has the value 3 because it was done as an explicit spreading of x, which means that it made sort of individual copies of those values. Okay, so when you want to copy an object, in other words, you need to be careful how you are doing it. This is not the end of the story. There is some notion of shallow copying and deep copying, which is that if there are further objects inside the object itself, it's not going to sort of go deep and copy each one of them individually. Okay, so that's something that you do need to keep in mind whenever you want to make a copy. There are certain helper functions that allow you to, that help to basically make complete copies of objects. When you are working with them, you need to make sure you're using something of that sort, right? In other words, just saying the assignment y equal to x is not good enough when you are trying to use objects, right? It only gives you a pointer and not a complete copy of the object.